हॅलो फ्रेंड, आज आपण construction of titration curve and choice of indicator in acid base titrations हा पॉइंट्स स्टडी करणार आहोत. पॉइंट फर्स्ट आहे टायट्रेशन ऑफ स्ट्रॉंग ॲसिड वर्सेस वीक बेस. In this case, the titrant use of strong acid like here use of HCl and titrant use of weak base like ammonium hydroxide, ammonia, aniline and hydrogen. These are the example of weak base. Here NH4OH. These are the example of weak bases which can used in this titration of strong acid as versus weak base. Now general reactions, suppose like NH4OH as a titrant reacted in presence of strong acid like HCl. Here the H plus ion and Cl minus ions, that is ionized form of the strong acid, to form the molecule like H2O plus NH4 plus Cl minus ions. Now at the start of the titration, only ammonium hydroxide, that is NH4OH, will be present in the conical flask. Therefore, the pH of the solution can be calculated from the concentration and dissociation constant of the base, that is NH4OH. As soon as that is NH4OH is a titrant, at the beginning of the titration in the conical flask there is only the NH4OH solution will be present. Therefore, the pH of the solution can be calculated by dissociation constant and concentration of the basic solutions. As soon as the some acid is added, like the HCl is added on this NH4OH solution, that is titrant will be added in the titrant, then the pH of the solution as well as concentration of the solutions decreases with the converting ammonium hydroxide into ammonium chloride, and it is the setup of buffer systems will be set up in the solutions. At the equivalence point of the solution, the ammonium chloride will be present, that is NH4Cl is present in the conical flask. Due to hydrolysis of the salt, the solution at the equivalence point will be acidic. Therefore, the pH will be less than the 7 of the solutions. The exact pH value can be calculated by considering the hydrolysis of the salt and the concentration of the salt formed at the equivalence point. After the equivalence point, when the excess of acid is added, the pH is determined only by the concentration of excess of hydrogen ions. Now the first case, consider the titration of 0.1 molar ammonium hydroxide, that is NH4OH. The Kb value of the solution, that is Kb is equal to 1.8 into 1.8 into 10 raised to minus 5 with 0.1 molar hydrochloric acid, that is HCl. The concentration of ammonium hydroxide, that is 0.1 molar, as well as the concentration of HCl will be 0.1 molar. Therefore, the pH value at the various stages can be calculated as a following manners. The first one, at the beginning of the titrations. At the beginning of the titration, at the beginning of the titration, in the conical flask there is only the ammonium hydroxide solution will be present. Therefore, the pH of the solutions can be calculated from the following equations, that is concentration as well as dissociation constant of the NH4OH ions. Now here the reactions, the NH4OH is only present at the beginning. Therefore, the concentration and dissociation constant of the NH4OH, the dissociation constant of NH4OH will be NH4 plus ions plus OH minus ions. If we can consider, that is the alpha is dissociation constant, and the capital C will be considered as the molar concentration, then the equation of the reactions, like the concentration of NH4 plus ion will be equal to concentration of OH minus ions is equal to the dissociation constant, that is alpha, into the concentration of these solutions, that is C, and the concentration of NH4OH is equal to concentration in the bracket, square bracket, 1 minus alpha into C. Okay, the concentration of the NH4 plus ions is equal to concentration of OH minus ions is equal to alpha into C, and the concentration of NH4OH will be equal to the 1 minus alpha into C. Therefore, the dissociation constant of this solution, dissociation constant that is Kb of the base is defined by the relation is relations is equal to, that is Kb is equal to concentration of NH4 plus ion into concentration of OH minus ion divided by concentration of NH4 OH will be equal to the in bracket alpha into C for the concentration of NH4 plus ions into alpha into C divided by 1 minus alpha into C. Here the concentration will get cancelled. It will get the alpha square into C divided by 1 minus alpha. For ammonia, the Kb is equal to 1.8 into 10 raised to minus 5. Therefore, the alpha square into C divided by 1 minus alpha is equal to 1.8 into 10 raised to minus 5. If the alpha is small, then the 1 minus alpha will be equal to 1, and equation like alpha is equal to under root 1.8 into 10 raised to minus 5 divided into concentration C, and the concentration of OH minus ions will be equal to alpha into C, that is equal to under root 1.8 into 10 raised to minus 5 into C. Now for 0.1 molar solution, for a 0.1 molar solution, the concentration of OH minus ion is equal to under root 1.8 into 10 raised to minus 5 into 0.1, that is the concentrations. It will get the 1.342 into 10 raised to minus 3. Now the POH is equal to minus log to the base 10 into concentration of OH minus ions will equal to minus log to the base 10 into 1.342 into 10 raised to minus 3. It will get, that is 2.87. Now the pH of the solution, that is pH is equal to 14 minus POH. Here the POH is, that is 14 minus 2.87. Therefore it will get, that is the 11.13. The pH of the solution is the 11.13 at the beginning of the titration. At the beginning there is only the ammonium hydroxide solution will be present in the conical flask, that is 10 cm cube of ammonia present in the conical flask. In the second case, when the 2.0 cm cube of HCl is added into the ammonium hydroxide solution, that is titrant, in this case the 2.0 cm cube of ammonia will be neutralized to form salt of ammonium chloride. For salt of ammonium chloride, salt of ammonium chloride and 8.0 cm cube of ammonia will remain unneutralized and the total volume will be 12.0 cm cube. Therefore the salt concentration of salt can be calculated by using the concentration of salt in 2.0 into 0.1 molar solution of HCl and the total volume will be 12. Therefore the concentration of base ammonia will be, therefore concentration of base will be, that is concentration of base is equal to 8.0, it again 0.1 solution of base and the total volume base will be 12. In this system is a mixture of a weak base and its salt ammonium chloride, hence the basic buffer. The pH of a basic buffer is given by the expression like pH is equal to pKw minus pKb minus log the concentration of salt divided by concentration of base. At 25 degrees Celsius temperature, at 25 degrees Celsius temperature, the pKw ionic product of water is 14. pKb is given is equal to, that is minus log to the base 10 1.8 into 10 raised to minus 5 and the concentration of salt divided by concentration of base, the ratio will be 2.0 divided by 8.0. Now substituting this value in the above equation, it will get the pH is equal to 14, that is POH minus 4.74 minus log 2.0 divided by 8.0, it will get 9.26 minus in the bracket minus 0.6020, it will get again the pH of the solution will be 9.86. When the 2 cm cube of hydrochloric acid added in the titrant, that is ammonium hydroxide solution, then the pH of the solution will be 9.86. When the 2.2 cm cube of HCl is added in the solution of titrant. These are the practice example. When, that is, you can calculate the pH of the solution when the 5.0 cm cube of HCl has been added to NH4OH solution. Calculate pH of the solution. And second one, at the vicinity of equivalence point, at the equivalence point when added 9.9 cm cube of HCl will be added to NH4OH solution, then calculate pH of the solutions. Okay, these are the two practice examples. When 5.0 cm cube HCl added in the NH4OH solution, and the second one at the equivalence point, the 9.9 cm cube of HCl is added to the NH4OH solution, then you can calculate the pH of the solutions for both at the 5 cm cube addition and 9.9 cm cube addition of HCl into the NH4OH solutions.